Okay, students, today we have to start the chapter number 2 of our physics, that is electrostatic potential and capacitance. First of all, you all should know about what is electric potential and potential difference. We have discussed in class 10 that there is no word that is electric potential. We have always discussed about the word potential difference. Same like in gravitation potential, we have discussed there is no word gravitation potential. We always study about potential gravitation potential difference and gravitational potential difference. So in 10th you all know about this formula. Potential difference is the work done by charge per unit charge is called potential difference, but in plus 2 we have to discuss it more. For example, potential difference between 2 points can be calculated. For example, if there is a point here and there is a B point, and we want to define the what is the potential difference between these 2 points, so we can say that if for example there is a charge here and we are bringing it here, so potential difference, that is VA minus VB, because final minus initial, this is final and this is initial, so VA minus VB is equals to work done in bringing from B to A and divided by this small test charge. And test charge, you all know, we always take it positive. So this is the potential difference, that is VA minus VB, and is equals to work done in bringing by from B to A point. This is the potential difference, not electric potential. This is the potential difference. So if you want to discuss the what is electric potential, we have discussed right now this thing, VA minus VB is equals to work done in bringing the from B to A unit positive test charge. Okay, so if you want to calculate the electric potential, the VB, it should be 0, or we can say infinity. By this trick we can define the definition of electric potential, that is if VB is 0, we can say that VA is equals to work done in bringing A to Q naught, and this is the electric potential at A. Electric potential at point A. So as I said, there is a no definition for electric potential. We by trick we can define is this, that is electric potential, and definition is work done in bringing a unit positive charge from point A to point B to A, or A to B. That is electric potential, that is work done in bringing a unit positive charge from one place to another, and its units are, you all know, work done is units is joule and charge is coulomb, so you can say the potential difference is joule per coulomb. So this is all about electric potential and potential difference, that is work done in bringing. So make your thing. For example, if I say this is B point and this is C point, the charge is going from this to this. So if we want to calculate the potential at point B or point C, if for example potential at B will be work done from C to B, if this path, for example, if charge is at here, अगर आप चार्ज को यहाँ से from here C से B लेके जाओगे, so it will be work done in bringing a C to B. If charge is at B, so we can say that potential at C is equals to work done from B to C in bringing a unit positive charge. So make these things remember in your mind, so if you want to get the electric potential and potential difference. Now we will discuss about our first derivation, or it is very important regarding your CBSE, that is electric potential due to a point charge. Electric potential due to a point charge, as far we have discussed only this thing, this VP to VA work done divided by test charge. But we have discussed, yeah, the work done from bringing to B to A, the test charge. So due to a point charge, for example, if I consider that here is a point charge plus Q, and I want to calculate the potential, electric potential at this point, that is point P, and here's a distance, that is, I want to take distance is R, from this point to this point, and I take this point infinity, and there is a test charge which is coming to P. And if it is coming to P, and I want to calculate the electric potential at point P, so what do you have studied? So we can say that electric potential at P is equals to work done in bringing a charge infinity to point P divided by this small test charge, that is Q naught. So, but you know, if this is electric potential at point P due to a point charge, okay, due to this point charge, we have considered these two charges, point charges, this is also positive and this is also positive. So we know work done, if we want to electric potential due to a point charge, we know we have to, that is V is equals to work done by Q naught, and we have to calculate this small amount of work done. You have to find this work done. So, and we all know work done is always force into displacement. We have done in work energy theorem F into dx, and for variable forces from infinity to this point, that is R, infinity से R तक जितना work done होगा, we have to calculate that. So work done will be F infinity to R, infinity से R तक. So when this small test charge will come here at point P, there will be a electrostatic force between these two charges, that is from Coulomb's law that we have discussed in chapter 1. If this charge come at this point, that is point P, because this is also a positive charge, it is also a positive charge, they will repel each other, and force is in this direction and displacement is in this direction. We are moving this side, now we are moving this side, and force is this side, and so there is an angle between force and displacement, that is 180 degree, and we all know work done is equals to F into dx cos theta, then cos 180 degree. So therefore work done would be, and cos 180 is -1, so minus F into dx. So our work done will be negative because force is in this direction and your displacement is in this direction. So from Coulomb's law, we can define that force would be, we all know that K into Q1 Q2 divided by R square. But for this equation, it will be K into test charge is Q naught, and our charge is Q, and distance is, we have taken it R, so it would be R square. So this is the force. Now we have to calculate the work done for this part. So work done would be this minus F into dx, and it would be minus K into Q naught into Q divided by R square into dx. So because it is a amount of small work done, small parts, we have to use the integration, infinity to R, we have to use the integration part. So it would be like work done is equals to F into dx, and for small work done it would be infinity to R, and that is what is a force? Force is K into Q naught divided by R square into dx. Okay, for dx you can also use the dr, because you are taking the variable of the radius, so we can take the variable dr. So it would, these all things are constant, and you will get it, that is K into Q naught infinity to R into 1 by R square into the R, and work done integration is dw. And those who are not getting the integration part, you all know the integration of x raised to power n is always power get increased, x into n plus 1 over n plus 1. So integration for this, first of all you have to this r minus 2, and with respect to dr, so it would be r minus 2 plus 1 and minus 2 plus 1, that would be r minus 1 over minus 1, or you can say that minus 1 by r would be the integration of this part. So it would be k into q naught into minus 1 by r infinity to r. So upper limit minus lower limit, kq minus q naught minus 1 by r and minus 1 by infinity. And you all know minus 1 by infinity is 0. First of all, one thing, that our work done was negative because cos 180 is minus 1, so this part would be negative. So work done would be, this thing will be 0, you all know that, and this would be minus k into q naught divided by minus 1 by r, and this minus will be positive. So our work done would be k into q naught divided by r. This is the final work done which we have calculated from infinity to that point P. So electric potential that we have discussed, electric potential would be V is equals to work done from, that is infinity to point P, and divided by test charge. Work done what we have calculated, that is k into q naught divided by r and divided by q naught. Q naught would be cancel out, and your electric potential at point P, we can say that kq by r. That is your final result, that is electric potential at point would be kq by r. And it is an additive in nature. If for example, if I give you one example, and this is your final result about, and you all know what the value of k is, because that is 1 by 4 pi epsilon naught, that is 9 into 10 raised to power 9. This is the value of k. Then it is additive in nature. For example, if I give you small example, this is q1, this is q3, and this is q2. They all or radius r at point P, and I'm telling you find the electric potential due to these point charges. In potential difference, in potential we have to take on the sign. For example, potential at P would be from this formula, k into q1 divided by distance r plus, according to this, k into q2 divided by r, and from this minus kq3 by r. You have to take the magnitude of the charge, that is if it is negative you have to take it negative. So this is all about the electric potential due to a point charge. So there is a numerical for you, have to try it. I'll discuss in the next video. That is, if I say that there is a plus q charge and here it is a minus 3q charge, and they are the distance, say like a dipole, but no, not a dipole, because dipole has a same magnitude as opposite direction. We discussed also dipole. You have to calculate where is potential, where is potential 0 on the line joining two charges, and your options are a by 2, a by 4, a by 6, and a by 8. I will discuss this numerical in next video, so try it and try to understand from your books as well. That is electric potential. This is your first topic, potential difference and potential due to a point charge. Next video I'll discuss about your dipole and the potential at equatorial plane, you all know. So please try this numerical, and next video I'll start from this numerical.